what is a transparent firewall? Until now, the firewall that we were doing, it was which layer device? Layer 3, layer 4. You used to check layer 3 IP addresses, layer 4 port numbers. So access lists used to match on port numbers as well as on IP addresses. Right? That was the one which we did until now. That was one mode of a firewall. There's also another mode. It's called transparent. Why would you use transparent mode firewall? In transparent mode firewall, this device loses the capability of routing. You can't use routing on the firewall. Let's have a look at why would we need it. Say this is one of the firewalls connected to the internet, and this is the company that I have. Inside the company I have a switch, and PCs are connected to this switch, right? Another switch is connected. Then eventually these are different VLANs. I have another VLAN here, and to this VLAN is connected a server, right? So the firewall can say this guy will have a sub interface, and that sub interface we can keep it on a different DMZ. So we have a different DMZ for this server. Or we could have another cable coming out from here, connecting here in a different VLAN. So this will be DMZ, and this will be inside. Right? So you can protect your DMZ using this firewall is protecting your DMZ. What most companies do is for their critical servers, the servers that are critical, what they would do is they would say, okay, we have it on the outside, we have firewall on the edge, but they also want to use security policies on this separately. So what they'll do is they'll get another firewall here. They'll get another firewall here and connect it like this. But this firewall will do what? Whatever traffic is coming in through the DMZ will not go straight to the server. It'll go into this firewall first, and then from the firewall it'll go to the server. But if you look at it, it's still in the same network. This whole thing is in the same network, right? This and this server is in the same network. Then you cannot keep this as a router here, because router cannot have two interfaces on the same network. It has to be on two different networks. So this firewall will not act as a router, will convert it to transparent. Transparent means it will have all the capabilities of a firewall. All the capabilities of a firewall, but except for it will not be doing any routing. It will be there, but on layer 2. Extra security for the server. Let's have a look at it from an easier perspective. How you will do this. I'll have R1 here connected to the firewall and R2 here. This firewall is going to be transparent. So this, if this is 10, 11, 11, 2, 1, what is this going to be? Both of them will be the same network, right? From R2's perspective, it's directly connected to R1. From R1's perspective, it's directly connected to R2. The firewall in the middle, they don't know it's there. Neither does R1, neither does R2. Now tell me this, if this was connected to the internet, R2's default gateway will be what? 10, 11, 11, 2. Nothing to do with the firewall at all. The firewall is useless there. Okay, in this term, obviously with security perspective, it has everything that you need. You'll have this on the outside, this on the inside. So in can go out, out cannot come in. You'll have to apply access lists for R1 to reach R2. We'll see all of that, but do you understand this concept of the transparent firewall concept? All you have to do is just change the mode of the firewall from routing to transparent. Okay, this is fine, but there is a problem. There's a little problem. What is that problem? Check this out. If I have a switch like this, switch 1, and I have ports on switch 1. Port 1 is connected to router 1. Port 2, router 2. 3 and 4 are connected to the firewall. They're all in the same VLAN, right? If they're all in the same VLAN, R1 wants to talk to R2. His packet will go straight to R2. Will it go through the firewall? They're all in the same VLAN. How do I make sure that it comes in the middle of the flow? See, if R1 is sending a ping to 10.11.11.2, the ARP will go out looking for 10.11.11.2. This guy will reply with the ARP, so the packet will go from R1 to R2. How do I make sure that the firewall, this transparent firewall, comes in the middle of all of this? Should be in the same VLAN. Exactly. So I cannot put all of them in the same VLAN. If I do that, it will not work. Although yes, generally when you want R1 and R2 to be in the same network, you do put them in the same VLAN, but you will not do that here. You will not do that on this one. This will be a little different. What? This will not be green. Again. R1, R2, then the picks. Right? So what I'll do is, I will not have this and this as green. I'll have this as green, this at VLAN 10, and this part as VLAN 10. This guy as VLAN 20, this guy as VLAN 20. Okay, so it'll be like R1 is connected to the picks, R2 is connected to the picks also. This, see, if you have a look at this, it'll be something like this. This is like that game we used to play. Okay, and the blue one will be connected where? So your packet that is going in will go in like this. It'll go through, reach the firewall, come out from here, go to R2. Okay, let's change the color. So if this is your packet coming from R1, will go into the picks. The picks will forward it to this port, from where it will go to R2.
But they would be in different subnet now.
In the VLANs will be different. The VLANs will be different, not the subnet. The subnet you will keep it as same. That is the thing. The firewall in the middle, transparent firewall, will join them together. Will join the two VLANs together as one. Think of it as ARPs. What is going to happen to the ARPs? Okay, let's think about that. Let's say this, now this is important, so keep your concentration. This is 10, 11, 11, 1. This is 10, 11, 11, 2. The firewall knows this. Firewall is connected, right? So he knows that blue on the other end is 10, 11, 11, 2. And he knows that green on the other is 10, 11, 11, 1. When you send a packet from R1, which looks like this, going from 10, 11, 11, 1 to 10, 11, 11.2, right? He needs to fill up the Ethernet part also. This will be MAC of R1. Now he needs this. Where does he get this? How does he get this? This part. How does he get this part? ARP. Right? So he'll ARP. A separate packet is sent. An ARP packet. What does the ARP packet look like? With the source of MAC A, destination is FF, who is 10, 11, 11, 2. Think about what happens to this ARP packet. This is a broadcast, so it will span across this VLAN. Which VLAN? The green VLAN. This ARP packet will go across here, reach which port? This port. This is whom? The firewall. He's asking basically who is 10.11.11.2. Does firewall know who 10.11.11.2 is? Firewall is not 10.11.11.2, but firewall knows that on the other end of the interface, I have 10.11.11.2. Right? Because firewall is connected like this. If you look at the logical of the firewall is like this. This side is, he knows it's 10, 11, 11, 1. This is 10, 11, 11, 2. Where did he get the ARP request from? The ARP request came in here, asking for who is 10, 11, 11, 2. Firewall is transparent in the middle. He knows 10, 11, 11, 2 is here. So he replies here saying, I am. Instead of R2 replying with his MAC address, R2 does not reply because the broadcast goes only in the green part. Firewall replies on this port saying, I am 10.11.11.2. He's replying on behalf of the router. Why? Because he wants the packet to be sent to him. Then he'll forward it as a proxy for the ops. Right? So now here, what address will be given? This one will be MAC of firewall Ethernet 0. This is E0, this is E1. So the packet will go to E0. Right? He will take this off. He'll take this off, but he will not see this. It's transparent mode. He doesn't care about this. Right? He does see, but he does not do any routing decision. He just checks the security level. Is the security level correct? He has no way of route lookup. All he has to know is, are they in the same network or not? That's all. There's no route lookup now. Everything else is the same. He will have the ACL. If you look at the boxes, he will have the ACL. He will have the security check. NATing. NATing, we'll talk about it tomorrow when we do 8.4. How it does NAT. Right? Leave that aside for now. There is no route lookup. There is no route lookup. It only checks this and lets him go. Right? So the packet comes in here. Now the packet is coming here. This exact packet comes in here. He removes this part. Now he needs to forward the packet to whom? 10, 11, 11, 2. He already knows that MAC address. Because of gratuitous ARP, it's already done. So he knows what that MAC address on the other side is. What does he do? He uses this source, E1 source, MAC E1 and MAC R2. MAC E1 and MAC R2. And forwards it where? From this interface to, with the source MAC address of this, destination MAC address of this. Is this clear? Questions? Last step. Okay, you understood how it gets here, how the packet comes to the firewall, right? How did he know 10, 11, 11, 2? How did he know that he has 10, 11, 11, 2? How did he reply with MAC address of himself? Why? Because once they see R1 and R2, once they connect up to the firewall, they do something called gratuitous ARP. Gratuitous ARP is they give out their MAC addresses and their IP addresses and they broadcast it out. So when it comes up, firewall stores both of them. He knows R1 is what MAC R1, R2 is MAC R2. He knows that, right? So now this when packet comes in here, now he knows where is he supposed to send the packet to? R2. He knows that because the destination is 10, 11, 11, 2. Right? Now the packet is still there. All he needs to do is fill up this. Which interface is this packet leaving out from? This one. So the source he knows already. What about the destination? It was there already because he had gratuitous ARPed him. So he has that MAC address table. Remember the MAC address table? He has that table.
It has a separate gratuitous ARP table.
Not gratuitous ARP. When someone gives you a gratuitous ARP, you do store it as an ARP cache table.
I thought gratuitous ARP only works during switching.
It works here too. Every router, whenever you configure an IP address, They do gratuitous ARP. How do you think they resolve everything? How do you think there's an IP address conflict? There's an IP address conflict whenever something happens. When you give an IP address to a PC, you get an IP address conflict. Why? Because it gratuitous ARPs and then gets the reply with someone else with the same IP address. Okay? Pick up your phone.
Sir, but here you tell ना our firewall is in transparent mode. वो उसको उस address से कोई मतलब नहीं होता है. It will not.
He doesn't care. See, he doesn't do any route lookup on this.
Then how can he knows कि उसे 10.11.11 2 पे भेजना है?
क्योंकि इसके पास दो ही इंटरफेस है. On transparent mode, you only have two interfaces, inside and outside. There is no DMZ concept here.
He's getting it from inside the
एक साइड से जाएगा, he knows that he has to throw it out from the outside. There is no concept of DMZ on transparent firewall. Inside, outside.
So it makes a decision on this matters.
The decision, which decision? This one? He gets it on this interface. He makes the decision that he's supposed to forward it out from the other interface.
there is no other interface.
There's only one interface, one and second. That's all he has. Right? You cannot configure a third interface. Only two interfaces. So if he is getting a packet from here, he'll always forward it to the other side. Only based on security checks. If your security check allows you, he will forward the packet out.
Why do we need a firewall in the internal network?
That's why I explained in the beginning. Remember, the servers are critical. Some servers are critical. So you have one on the edge for your whole company. Then for that server, you need another firewall to protect it from your inside users also. Separate firewall for the server. But that one you keep it as a transparent firewall. Because it'll be on layer 2. Okay? We'll configure it and we'll see how it goes, how it happens, and we'll be more clear about it. Okay? I won't connect it directly now. If you wanted to do it directly, what you could do is you can connect it R1 like this, then transparent firewall in the middle, and R2. It'll work like this, easier. But I want to show you this way. What I'll do is I'll get this in. This guy. Right? So we'll do some switching in it. Yes. It's an L3 switch. So I'll get one firewall here, one router here, another router here, and the PICs. Okay. Disconnect them. One will be connected to 1, 2 will be connected to 2, and PICs will connect it. E0 will be our inside. E1 will be the outside. So E1 will be connecting to R1, R2, E0 will be connecting to R1. Okay. Start it up. I don't want any configuration. आप ही को ढूंढ रहा था.
So which class going on?
Huh?
Which class?
Right now it's firewall. Okay, so this is not a router, is it? Yeah. Host name is switch 1. So let's see which VLANs. I need two, VLAN 10 and VLAN 20. PICs R1 and R2. Tell me which ones do I need to put in VLAN 10?
Easy.
F11 and F10. F10 and then F1 should be in VLAN 10, right? Let's do that. Conf interface FA interface range FA 1 10
I
FA1 1. Switch port mode access, switch port access VLAN 10. Similarly 11 and 2, that is E1 and router 2. Switch port mode access, switch port access VLAN 20. Let's check. 1 and 10, 2 and 11. 1 and 10, 2 and 11. So E0 is, R1 is connected to E0, R2 is connected to E2. Okay, good enough. Let's go to R1 and R2. R1, R2. Check this out. Conf T interface FA00. IP address is 10.11.11.1. No shut. Loopback 0. That's all I do. And R2 10.11.11.2. No shut. Loopback 0 is. Right now, do you think R1 will be able to ping R2? Even if the firewall is in the middle transparent, it will not be able to ping. Why? Because not different. Firewall, even if I allow it from the firewall, I make the firewall transparent, it will still not happen. Why? It's not inspected. Firewall does not inspect ICMP. Everything works the same exact way. Just so that you don't confuse yourselves, the actual topology now looks like this. Connected to the PICs R2. This is the actual topology with E0, E1. This is how the actual topology is. So if I ping from R1 to R2, it won't happen. Although they are on the same network, it will not happen. Telnet, yes. Why? It's TCP. Telnet is TCP. Okay, I'm not there yet. I haven't configured the firewall. I have to do some other stuff before I make it transparent. Let's see what those things are. First things first, I'll disable my CDP. Better than doing my speed duplex. No CDP run. So what I'll do is, not here, my firewall. Two R1s. Here. Right? My mode is single. I don't care about that. The command is firewall. That's all. Check out. In my interfaces, my IP address command is gone. You cannot give an IP address anymore to interfaces. But you still need to specify your inside and outside. You still need to no shut your interfaces, obviously, because physically they are down. Physically these two interfaces are down. I need to bring them up. Say this is inside and this is outside. Interface Ethernet 0. Name if inside. No shut. That's all. Interface Ethernet 1. Name if outside. No shut. That's all. Both are up. But check this out. It will still not work. Still not work. Why? It's because it is the same concept we used in EasyVPN, if you remember. Remember easy VPN, we were making a tunnel, we needed to do that IP unnumbered 00. Why did we do that? To bring the IP stack up. Right now, Firewall's IP stack is down. It cannot do anything. Any IP packet that comes to it, you will not understand what it is. I need to bring an IP stack up. For that, I would need to give it an IP address. Does that IP address need to be in the same network? No. Any IP address which you want to do, it will work. But yes, in real life, you will always give it an address in the same subnet. In real life, so that you know which subnet does it belong to. But not necessary. You can give it any address. Let's say I want to give an IP address here. You'll say, hey, you have the command. Let's try. Not 1.1. Different subnet. But check this out. When I give this, it comes back to which mode? This IP address did not go to the interface. It went to the firewall as a whole. So the interface or the firewall does not have an address. The whole thing has an address. The whole device. Just like you might have seen on a switch, we do this. The switch does not have IP addresses on its own, but it gets an IP because we use that IP to remotely manage the switch. If you want to do telnet into the switch, we used to give a VLAN and IP address. Same thing here. You can telnet into this. If you want to manage the transparent firewall remotely, you can use this address. Two jobs of this address. First is remote management. The second is to bring the IP stack up.
Does that mean that if I give the IP address to Ethernet one, it will do the same thing?
Check this out. Show, run. Where did I give it? Do you see IP address here? No. The IP address comes in the global config mode. If you give anywhere, it will still come here. And it will overwrite it. If you give a new address, it will overwrite this old one. Why I showed you there is to show you that you cannot give IP addresses to interfaces here. Clear? Everybody? Now, let's try. It's working. Let's enable VTY on R2 as well as R1. Right, so telnet. My telnet is working. Let's check this. Connection entry is still there. Clear? Questions? No questions? No R table? But a MAC address table. It's acting like a switch. It's acting like a switch. On the inside, it has learned 2 addresses, and on the outside, it has learned 2 addresses. Let's check who's this address. Let's go into R1. Show interface 00. This is C204. R1, right? And let's try here. So C204 he has learned from the inside. Then who is C201? On the inside, right? This is 00AB. It has nothing to do with this table. So it doesn't participate. Where? Here. But if I check my R table here, what is it going to? Right? 10, 11, 11, 2 is represented by C202, which is this guy. C202. What do you get from this? Is a question to you guys. If you check here, if from R1, right? R1's 10, 11, 11, 2 is C202, 1914.
R2's interface.
R2's interface. R2's interface. But who's representing this interface?
There's
The firewall is. The firewall is represented. If you want to check this, we'll check it on the switch. How? Ten. He's not showing all. He's not showing it for the firewall. It has issues, this one. This layer 3 switch has a lot of issues. So he's not showing it. He should show you that on VLAN 10, this MAC address will be represented by the firewall. And on VLAN 20, this MAC address will also be represented by the firewall. So R1 thinks he's talking to R2. He thinks he's sending his packet to R2, but who's replying with that MAC address? See, I'll tell you how it goes. MAC address here is C204. MAC address here is C202. Okay. When the beginning it becomes a transparent firewall, they have their gratuitous ARPs, right? So this eventually the firewall has a table like this, which says E0. On the other side of E0 I'm getting C204. On the other side of E1 I'm getting 202. He knows that, right? This is the MAC address table on whom? The firewall. Now what happens is R1 sends an ARP who is 10, 11, 11, 2. This ARP reaches which interface? E0. It reaches E0. Firewall has this. What does it do? This ARP does never reaches R2. Why? Because they're separate VLAN. So this ARP will not reach R2. It will reach the firewall. What the firewall does is he knows on the other interface he has 202. So he replies and tells him, hey, listen, I am 202. He's looking for 10, 11, 11, 2. He tells him, I am 202, 10, 11, 11, 2. My IP is C202. So R1 thinks, okay, fine. He starts his packet like this from 204 to 202 with the same IP of 10, 11, 11, 2 and sends it to whom? The firewall. The firewall receives it, strips it off, attaches a new header with the source as this and destination as this, but from here to here. Then he just forwards it to the other side because he knows the destination is 202. He's looking for 202. This transparent firewall never ARPs on its own. It doesn't ARP. It uses the MAC address table only. Think about this. He gets a table like this. He gets the packet like this, right? What does he check? Which table? Which table does the firewall check? The MAC address table, right? He checks the MAC. The destination is what? 202. He checks the MAC. 202 is which interface? E1. So he forwards the packet out from E1. The packet reaches whom? R2. Is this clear? Any questions? No? That's not possible. Should be questions. Yes?
इंस्पेक्शन में कैसे पास करेगा?
Inspection? There's no inspection right now. Inspection हम करेंगे इस पे बाद.
So, what if there's another router
Mhm.
connected to switch from the same VLAN?
This switch? Where? Here. In the same VLAN. That won't be on the same IP address, right? That'll be on a different IP address. right? At that time, this router will not reply because in his MAC address table, he will not have that address. It'll be connected somewhere here. So this guy will never have it in his MAC address table. He'll just forward it directly to that guy. He'll receive a reply. He will not wait for this side. Okay? Is this clear?
He shouldn't make it this table
On
of
firewall, yes, sure. Spring, telnet. Inside and outside, 204 and 202. That's all he has. 204 from here, 202 from here. Right, that's what he uses.
Previously there were 4 make it.
They were, yeah. This one, right? 201 F10 201 F1, probably from the switch. Yeah, F101 F10A, so 10 and 11. 10 F10A and F10A, and 11 will be F111 F10B, यही वाले थे दोनों, these two, F10A and F10B, the physical addresses of the switch, because this is also somewhat like a switch. This is also somewhat like a switch.
So now there is no relation of IP. I mean, it will not work on IP address.
Not at all.
So will access list and all works?
That will. He checks the address. He checks the address, but he doesn't do any route lookup decisions. The header is visible to him, but he can only read the header for access list. He cannot go inside the header and make a routing decision and route the packet. Basically, he can never go from one network to another network. He can see the IP address. He can make decisions on whether to drop it or forward it based on those addresses. He can even see the port numbers. He can see the full packet, but he doesn't make any routing decisions now. No routing is done. He's transparent to routing. Is that clear? So access lists will work, but there will be no routing. You saw right now the firewall, I'm putting it on a different subnet completely. His 10 is 100.11.11. But he's still working as a transparent firewall because it does not require the IP address. The packet never comes to him. Okay? But in case you wanted to manage this firewall remotely, what you would do is you would put this firewall on the same range. And you'll enable telnet. Right? So R1 should be able to telnet where? To 10.11.11.10.
So firewall learns the MAC address of R1 R2 when same as switch.
Just like a switch, yes. Exactly like a switch. From the ARP he takes the source. From that ARP he takes the source, so he remembers both.
First time it will.
Yeah. But he doesn't know the IP addresses of them. Firewall does not know right now what the IP addresses are on the other side. He just knows that one interface is incoming, one is outgoing. So either it's coming from here to here or there to there.
When it doesn't know the IP addresses, how can it block on the basis of that?
He can see the IP addresses of the packets that are going in. फिर जो आपने access list में whatever you write in the access list that block this or let this go, he will let it go or he will block it. He can see them. The packets are still going through it. But routing decisions will never be made. Usually when you have a router in the firewall in the middle, it acts as a router. So this is a different network, this is a different network. A packet comes from one network, he routes it to the other network. Now he doesn't have that capability. He will get a packet, let it go out from this interface. In the middle, he'll just be there, just monitoring. That route lookup part is reduced. Everything else is available.
And there are only 2 interfaces.
Only 2 interfaces, inside and outside. Okay, let's try to do one thing. Now tell me one thing. In a normal firewall, when you used to run updates, routing updates for example, where would you run it? Routing कहाँ run होती थी? You used to run it on R1 and then on the firewall. How about now? Who will be your routing neighbors? R1 and R2. But there's a firewall in the middle. Will that cause a problem? The update going from R1 to R2. EIGRP updates, for example, will they go? R1 to R2, will they go? Yes or no?
Yes.
EIGRP updates. How about RIP updates? They will not go. None of them will go. None of them will go. Transparent Firewall by default does not forward multicast or broadcast traffic. Except for the ARP, multicast traffic not forwarded. You have to specifically create an access list telling him to forward.
But RIP update works on
UDP.
UDP.
But the destination is 224.0.0.9.
Will use
So although UDP will be inspected, but the destination is 224.0.0.9, he will not forward it because the source and destination are not the same network. He can see that. He can see the packet is trying to go a different network. So he doesn't forward it. It's transparent, right? It should be the same network. That is the whole purpose of transparent firewall. For multicast addresses. For multicast addresses. Not only that. Yeah. Not OSPF. EIGRP and OSPF तो ऐसे भी नहीं चलते. They wouldn't work anyways. Why? Because they are not TCP UDP. RIP is UDP, so there was a chance for RIP to work. If RIP unicast is you're using RIP unicast, one side of the update will go. The other side will not come because security level. These are not connection entries, these are separate RIP updates which work on UDP. What does RIP work on? UDP port number 520. 520. Right now I don't want to go there. Right now what I want to do is basic. I want R2 to be able to talk to R1. Can right now R2 telnet? How do I allow him telnet? Where?
On
Fix. What do I say in the access list? Access list. Name it. Permit or deny? Permit what? TCP. Source.
So 10.11.11.2.
Destination. 11.1 equal to 23. Access group. INF in interface. Let's try. R2 to R1. Right? Just like a normal firewall. Just like a normal firewall would work. That's how it's working too. What else? I'm running grep here. I'm also running No auto. Will this work? Think about the updates that are going from RIP. Tell me, what do the updates look like? What is the source of the updates? I'm talking about R2 to R1. What is the source? Destination? What is the destination of a RIP update? 224.0.0.9. Source port? This is your RIP packet. What does it look like? 10.11.11.1. Destination 224.0.0. Source is 520. Destination is 520. Then you have RIP. Then you have RIP at the top. Layer 7. Okay? Good? So if this is the packet 520, now this packet is going from 2 to 1. Where do you think it is stopped? Why?
Destination is 224.
Before that, security level. Right? What was the checks? If you remember the checks, ACL, then security level, then NAT, if NAT is happening. क्या? Con table अब बनाएंगे ना फिर, but there is no con table here. Why? Because it's a RIP update. There is no connection made in RIP. Right? So if this is the case, that means we'll create an ACL which will bypass all of this. An ACL which will bypass this traffic. Which one? This part. Tell me what the ACL will look like. What should I write in the ACL? Access list. Permit or deny? Permit what? UDP source. To destination equal to 520. Right? Let's do that. Paste it on the firewall. Now this access list is already applied, so I don't care about anything else. I just need to apply this. Right? Access list is set. I have a hit count already. That means on R1 I should have R1 I should have 2.2, which I do have. What about the other side? On R2, should this have 1.1? Doesn't have. Why? We need to apply access list outgoing also, from inside to outside. Not because of security check. Security check is not the problem right now. The problem is these are different networks. He's trying to go multicast. For multicast, you have to specifically allow him. You have to tell him, hey, listen, I know the traffic will come from 10.11.11.1 to 224.0.0.9. Let him come. I know that's my traffic. I want you to let it come. Why do they do this? Why this is not done on the firewall by default is for security reasons. For security reasons. You don't want, see, when you have a firewall on your server connected on that VLAN, you don't want any traffic to come to that server from another VLAN. from another subnet. That's why this rule is there. But since I know I'm running RIP, so I'll specifically tell him, hey, listen, 224.0.0.9 will come, let him come in. So I'll have to specifically, on the firewall, create another access list, OBF, outbound filter, which permits what? UDP, source 11.1 to host equal to 520. Good. Access group OBF in interface, which one? Inside, not outside, inside. You have 1.1. It was not there before, now it's coming in. Very important from exam perspective. Run routing protocols through Transparent. You run it like this. You need to open access list, but again, you have to be as specific as possible. I could have said UDP any equal to 520. That's not being specific. You have to be completely specific about what to run. Good enough? Now, this is done. How about OSPF? Try to do it for OSPF on your notebooks. Using unicast routing, then you would just have to do it from down to up. Okay. From up to down, it will go automatically because it's UDP. Okay? Try to do it for OSPF. I'll actually do this. हो गया? Permit post this. Zero 006 क्यों? 006 is used for DR.
5
Hmm?
5 or 6 use करते हैं.
5.
सर इसका मतलब रिप इनेबल है तो 1.1.1 को टेलनेट कर सकते हैं हम लोग R2 से.
1.1.1 को
टेलनेट कर सकते हैं R2 से.
हाँ
तो रिस्पॉन्स आएगा वो कनेक्शन एंट्री उसका बन के आएगा.
हाँ
So उसका
रिस्पॉन्स के लिए कनेक्शन एंट्री अलग से बनेगी बट यू हैव टू बी श्योर व्हेन यू आर डूइंग telnet 1.1.1 the MAC addresses that will be used are local already, always local.
लोकल मतलब
समझाता हूँ, I'll explain it. गलत गलत एकदम गलत. There you go. You asked the question about unicast, right? I used unicast on R2. I received the route on R2. But the route was not received where on R1. I removed all the access lists. It's coming from R1 to R2 because it's getting unicasted. It is still unicasting from R2 to R1. But the security level is stopping him. So to let it go, all I have to do is access list INF permit UDP from host 10.11.11.2 to host 10.11.11.1 equal to 520. Access group INF in interface. Give it time, it will work. It's 30 seconds, rip is slow. Did you do the assignment which I gave you? Anybody? OSPF? नहीं किया? नहीं आता क्या? You don't know how OSPF works? Yes. Correct, but the most correct until now. अभी तक. There you go, 2.2. Okay. All I did was access list from unicast to unicast equal to 520. What I was doing it until now was from here. See, this is unicast now. I converted RIP into unicast. I used the neighbor command, which unicasts. So he doesn't send it .224.0.0.9. He sends it directly. Now, when that happens, do I need to create an access list going from up to down? Going from R1 to R2, do I need to create an access list? No, because it's a unicast. I only do that for multicast traffic. So from in to out is okay. But from out to in, I needed to create one access list from 10.11.11.2 to 10.11.11.1 to allow RIP. So down to up, I needed to create one. From up to down, I did not need one. That is not the question right now. The question is OSPF. How does OSPF work? Think about it. OSPF works this way. You have OSPF running here, OSPF running here. Usually OSPF sends its update to 0.0.5. If there is a DR, it is sent to 0.6. So you have to be very careful about the topology that you have. If you know that you're going to have a DR, use 224.0.0.6. If you know, if you're very specific, it's a point-to-point link, then don't use it. If it is a point-to-point link. Then, OSPF, at the same time, for some of the packets, if it doesn't go on multicast, it sends it unicast also. The database description, if you know, if you remember. See, hello packets are sent multicast. Then the DB descriptions and the networks, LSAs, are sent unicast. So you have to apply both, all three. Which ones? 224.0.0.5, 6 plus the unicast through the firewall. Have to be careful here. If there is no DRBDR, if there is no BDR, no need for 0.0.6. But unicast is the most important. Okay, let's try to do that. Let's try to run OSPF now. Remove RIP. Clear configure. क्या बात है? Access list and access group. Okay, we have R1. What do I need to do on R1? No router RIP. Router OSPF1 network area 0 and network area, right? Let's try to do it on the other side. Same thing. No router RIP. Network 10.0.0.0 area 0 network area 0. There's no neighbor relationship coming up. Both sides. Why? From the top, who's stopping it? 224.0.0 because it's trying to go on multicast. From down also, same problem. So first I'll try to fix from in to out. Access list OBF. Permit what? Permit which protocol? OSPF. Host is 10.11.11.1. Destination is what?
224.0.0.5.
There is no protocol, there is no port number here. It's OSPF. OSPF is OSPF. That is IP protocol 89, the one we were talking about. IP 89, it's not OSPF 89. Okay, done, and I'll apply it. Access list, access group, OBF in interface inside. R2 will receive a hello packet now, but R2's hello will not go back up. R2 will receive a hello, but his hello will not come up. I need to apply that also. How? I'll create another access list, INF, permit what? OSPF from host 10.11.11.2 to host, right? Access group INF in interface. Now the hellos are being exchanged, but it is stuck in which phase? X start. It will not cross X start. X start means exchange start. They are exchanging their routes, but they are not getting exchanged. Why? Because destination. Now it's unicasting. The first few packets are, if I have Wireshark running, I'll show it to you. Yeah, see, now it's unicasting. The multicast traffic did go through. The hello packets were multicast. Those did go through. These are your OSPF packets. They did go through. The moment they went through, DB description was sent, which was uni. And uni is not allowed now. Well, you might ask, from top to down it should be allowed. Is it allowed from inside to outside? It's not now, because I've applied an access list and it has a deny any. Remember? Access list में deny any होता है ना? So the access list only allows one guy, one to come out. What is that? Let's check the OBF. It only allows this to go out. 10 in unicast is also stopped now, from inside to outside. How do I let this happen? How do I allow this? I'll create access list, same access list, permit OSPF from host to host. Also have to allow it from the other side. So he is receiving it, but he can't reply back. He needs to reply back, coming back here to 1, from 2 to 1, access list, INF. The access list is already applied on the interface. It has gone down. We'll try to come back up again, because it tried to stay in X start for a long time. Init, trying to init, let them do that. There's your packets going on from one to the other two back, the same guy back again. See, there's no 224.0.0.6, so you don't have to worry about that. It's a point-to-point link. But if there was a, see, transparent firewall, mostly you will not have a DRBDR. Mostly. Loading has been done. My neighbor is up. Show IP route. I have a route. Which one? 2.2.2.0. Good enough? So if this is done, the third protocol that is left is EIGRP. EIGRP, just like OSPF, also uses unicast, just like OSPF. So multicast as well as unicast. But what is the multicast address? .10, 224.0.0.10. Now I want you to do this from R1. I'll telnet 2.2.2.2. Will it work? Why is it stopping? Even if I telnet? Why? Tell me why. Why is this not going through? Deny any. Access list, right? Not here. Here. Access list, right? So it's not allowing everything. My data is also stopped now. I need to allow my data. How do I allow? See, inside to outside, everything should have been allowed. By default, generally, it should have been allowed. Right? Now, to make it act like exactly like a normal firewall, you can do this. Access list, OBF, permit, TCP, any, permit. That's how a firewall works, right? From inside to outside, TCP is allowed any, UDP is allowed any, but a connection table is created so that a return entry is allowed. So now this works exactly like a normal firewall. Let's try now. Should this work? It works. How about this? How is this working? But it's going to 2.2.2.2. I want you to tell me how it works on packets. How does the packet look like? How does the Ethernet header look like? When I ping 2.2.2. Do it on a paper. I ping from what source? Destination is. Now to this packet, this will be added here, right? How does this work? This is a transparent firewall, right?
R1 MAC address source and MAC address of firewall will be this.
MAC R1.
Firewall
It'll be MAC R2. First of all, why? Because R1 knows that the route to go to 2.2 is through 10.11.11.2. If you look at the routing protocol on R1, show IP route, what is the next hop? So R1 knows to go there, he has to go through 10.11.11.2. Now he requires the MAC address of 10.11.11.2. How does he get the MAC address of 10.11.11.2? He ARPs to the firewall replies with R2's MAC address. So the MAC will be R2, but the packet will be going to which interface? E0. Then the firewall acts exactly like a switch, looks at this, checks the MAC address table, checks the destination is this, checks the port number which is leaving from, and forwards it out there. Does not check this. Right? Does not care about this 2.2 right now. Why? Because this is resolved for him. He has the next destination to go to. He right now does not care if it's going to 2.2 or wherever he's trying to go. Clear? Good? He does not, see, the good thing about you guys is he does not care about route lookups anymore. For him, route lookups don't matter. He doesn't have to look at the routing table to route the packet. All he cares about is it's coming from one interface, it has to leave from the other interface. It should only match the access lists. If it matches the access list, let him go. If it matches it, block. If it matches the deny, he'll block. If it matches the permit, he will let him go. Is this clear? Any questions?
He had entry for 10.11.2.
Which guy? Yeah.
Text,
Pix, yes. 10, 11, 11, 2.
Not of 2.2.2.
Not of 2.2.2. That's what I was trying to tell you. It depends on R1's ARP. R1 is ARPing for which address? 10, 11, 11, 2. Next hop. So he ARPs who is 10, 11, 11, 2. Who replies on his behalf? E0. So the header, Ethernet header says what? MAC R2. So Ethernet header will take the packet where? To the PICs. The PICs will eventually, he will not look here, he will not make a routing decision. That's what you have to understand. He will not make a routing decision based on this. So he doesn't need to know the route. All he needs to know is which MAC address to throw it out from, which he knows from the MAC address table. He knows which interface to throw out the router from. So he can remove this, check it against what? His access list and everything else which he has, if he has any access list. Closes it back, uses the same header and moves it outside to R2. Clear? Any questions? No questions?
So just the return packet from R2 now.
R2. R2 needs to reply to 10, 11, 11, 1. Right? Now if he wants to reply to 10, 11, 11, 1, the packet will look like this. Source is 2.2.2.2. The destination is ops for what? See, source is MAC R1, R2. Ops for who is 10, 11, 11, 1? Because for this guy, next hop is 10, 11, 11, 1. So ops for who is 10, 11, 11, 1? Firewall replies with E1 saying this is 10, 11, 11, 1. But the MAC address that he gives him is of R1. So it tells him E1 is R1. So R2 thinks he's sending it to R1, but he's actually sending it to the PICs. Because PICs' job is to combine the two VLANs together. So he does a little bit of hera-pheri.
So
This MAC address he shows it on this side, this MAC address he shows it on this side.
That is okay. In inspection table,
Yeah.
a connection entry is created. That's why it is going back from outside to inside.
From outside to inside, yes. So you want to see how it goes back from outside to inside? See, that is the thing. This header, the job of this header is to take this packet where? Back to the firewall. Through the switch. That is the job of this Ethernet header right here. Nothing else. When it goes to this firewall, he removes this part. Comes back here. Checks the connection entry. First thing is connection entry, right? Here it is the connection entry, the brown one which we always have. This is the con table. Con lets him come in, doesn't check the ACL, takes him straight up. Now there is no natting or nothing is happening, it just goes straight out. Right? Check the connection table. Let's have a look at that. Yeah. लगाता हूँ. Check the connection table. Two dot 2.2 is out. 10, 11, 11, 1 is in. Why? The connection table is based on this. Because he does remove, if you remember, he does remove this part. He does come in here. When he's letting him go out, he creates the connection entry for him to come back in. So when the same packet is coming in here, connection takes him out, doesn't need to check the ACL, goes back straight up. Okay? If you understand this, answer me this then. Right now, this situation, will this work? Show IP route first. 1.1 is there. If I do telnet 1.1.1.1, I'll give you everything. Show, run, access list. These are the access lists that I have. Okay. These are the access lists. Can I do this? How do I do the screen, two screen ones? This is the access list. No, I don't want to do it like that. These are the access lists. My job is from R2 telnet 1.1.1.1. My topology is right here. This is the topology. Will this work or not? Think about it first. Think about it and then answer.
There is no access for 1.1 security level.
How many say it will not work? 1, 2, 3, 4, 5. Only 5. How many say it will work? 1, 2, 3, 4, 5. 5 say it will work. The ones who say it will not work, where will it be dropped? Security will be dropped. Let's think about this. The packet is trying to go from R2 to R1. How does the packet look like? Telnet is, source is 11.2, destination is, right? I don't care about that part, I care about the Ethernet part. My source is MAC R2, destination is MAC R1. Why? Because next hop is R1. Next hop is R1. Whatever packet they are sending, their next hop will always be each other. R1's next hop will be R2, R2's next hop will be R1. So no problems there. But this R1 is actually E1. So the packet will be thrown off to the firewall. The firewall will do what? Take off this part, check this. Is this going from, see, first thing is ACL. Does he have an ACL?
No.
There is no ACL entry which says 10.11.11.2 to 1.1.1, right? I have to check INF because I'm coming from out to in. INF, there is no ACL entry which permits 10.11.11.2 to 1.1.1. What is the next check? Security check. It's going from out to in. Will it be allowed? No. Because it's going from out to in, it will not be allowed. Right? So to allow it, I'll need to do this, configure this access list, which will let this traffic pass on to inside. Okay, let's do that. Is this clear why? So I'll go into the ASA. Let's check first if it's working or not. It will not work. I need to go into the ASA, access list, INF, permit TCP from host 10.11.11.2 to host equal to, now let's try. Okay, clear? I did 2 protocols, you'll do 1 more, which is EIGRP. We'll do it with EIGRP. Try it with EIGRP first, then do the others. Okay, relatively simple. It's just like OSPF. But OSPF, you have to be careful that if there is DR, BDR, you will have to use that third command, which is 224.0.0.6. You'll have to do that. If it's not there, you don't need to. Okay? Clear? The one other thing that is left in this is called ARP inspection. There's one more thing left in here called ARP inspection, but we'll do that after the break. Alright, so before the break, when I was telling you about the security levels, like one of the students came and he was right, I was wrong about one thing. When I said the packet is coming back in, it will be checked against the ACL. Remember there was an ACL applied already? The ACL was applied already. So the ACL would block it, not the security check. The ACL had a deny any, that would block it. But yes, if there was no ACL even, then the security check would. But in both the cases, the solution was the same. In the ACL, provide that one line which lets it go out through the firewall. Exact match for the traffic that you want to get through. Alright, so I've cleared everything now. PIX is free completely. There is no access list enabled, everything is fine. So R1 will be able to reach R2, but routing protocols won't run right now. Routing protocols are not running, but I don't want to do that right now. I want to do some other feature. The last thing that we're going to do in this is called ARP inspection. Before we do ARP inspection, I want to visit back our ARP spoofing attack. We have done this in SNRS, but some of you were not with me in SNRS. So I'll repeat the ARP spoofing attack, which we also did in the class, if you remember, using Kali Linux. We did the ARP spoofing. Remember I showed you how to do ARP spoofing?
Yes.
So we'll visit that again and we'll see how ARP spoofing works, how that attack is carried on. What happens is, let's remove this. You have a switch. On that switch is connected R1. On that switch is connected R2. Also, before I go there, I also want to make sure that you understand this. I told you on the firewall, you can have how many interfaces? Only 2. I have configured those 2. If I go interface Ethernet 2, name if DMZ. What does it say? Interface is already configured. On a transparent firewall, you can only have 2 interfaces, inside and outside. Okay, let's leave it here. Move back to what we were doing. Now I have R1 and R2. R2's address is 10.11.11.1. R2 is R1 and R2, right? And say there is a default gateway here somewhere. There is no firewall in the middle. I'm just showing you how ARP spoofing works. So R4 says the default gateway 10.11.11.100, right? Now when R1 wants to go to 10.11.11.100 or his default gateway, he sends out a packet from 10.11.11.1 to 10.11.11.10, and then he needs to put his MAC address in. So MAC A and MAC R4, MAC 1 and MAC 4, sends the packet back to R4. What happens with ARP spoofing is this guy here is the rogue guy. He's the rogue guy. What he does is he maliciously sends out an ARP reply to R1. So in that ARP reply, the packet looks like this. It's coming from MAC 2 going to MAC 1. He sends it directly to R1 saying, I am 10.11.11.100. Sends this ARP to whom? Directly to that guy. The switch doesn't know what's happening. The switch does not know what's happening. He doesn't care because he doesn't check this packet. So he sees the MAC 1, MAC 2, forwards it to whom? R1. When the packet reaches R1, now R1's ARP cache says what? 10 is MAC 2. Earlier it was MAC 4. Since he got the ARP reply, he thinks that it's updated. The IP address has changed. The MAC address of the guy has changed. So he also updates it here. Next time when he wants to send his packet to 10.10.10, 11.10, what does he do? Who does he send it to? Source is MAC 1, destination is MAC 2, not MAC 4, MAC 2. The packet reaches R2. R2 strips it off, attaches another header. The source he keeps it as MAC 1. The destination he changes to MAC 4 and sends the packet out. So the packet which was going straight up doesn't go straight up now, goes to R2 first, then goes out. Man in the middle. R2 is your man in the middle. To prevent this from happening in SNRS, what did we do? We enabled this feature called ARP inspection. We enabled this feature called ARP inspection where we said, listen, 10.11.11.100 is on the switch here. Move this. we said that on this switch 10.11.11.100 is MAC 4. We bound it. So later, when this guy sends an ARP reply, it goes through the switch. The switch has now the capability to check all the ARP replies. He checks inside. What is he saying? He's saying 10.11.11.100 is MAC 2, which is not true because 10.11.11.100 is MAC 4. So he drops this reply. He doesn't let this reply reach R1. If this reply doesn't reach R1, R1's up the table is still 4. So he'll always send it to 4. That was done on the switch, ARP inspection. Now if you ask me which one is the better way of doing it, on the switch or on the firewall, switch is definitely better. Why? Because see, right now this is static, but in a production environment, all your IPs are dynamic. Most of your IPs are dynamic. The switch has that feature called DHCP snooping, where all the addresses given by the DHCP server are also stored in a table, and he checks ARP replies against that table. The firewall does not give you that capability, but they did include the capability of ARP inspection on the firewall, which can be done manually. You have to enter everything manually. Like you want to tell him 10.11.11.1, the MAC address is this. 10.11.11.2, the MAC address is this. So 10.11.11.2 cannot be represented by anybody else. 10.11.11.1 cannot be represented by anybody else. Okay? Clear? Now, there are two terms, yes.
If in the production environment, where direct addresses change, maybe someone moves from this section happens and direct address changes, then why should the switch bind it to a particular MAC address since the address is changing?
See, when it's a switch, right? When you remove it, the entry gets removed from the DHCP binding table also. When you remove it, right? So when you attach it again, he gets a new address from the DHCP. The moment it gets that new address, DHCP binding table is created again for that new address, right? That is on the switch. On the firewall, not such capability. On the firewall, when you attach it on a different interface, you have to specify it that I have done this. My new port is this. Okay? Now since this is done, what we'll do is we'll see how this works. I will attach, I don't have R4, I only have this. On the firewall, I only have 2 devices connected. So we'll see how ARP inspection works on these 2 devices, these 2 ports. What I can do on the firewall, since again only 2 ports are connected, right? So you don't have to worry about anything else. What I can do is I can tell the firewall, listen, 10.11.11.1 is this MAC address, 10.11.11.2 is this MAC address. So tomorrow no one else can come in. If he changes his MAC address, some other device is attached to the same port, it will not work. But there's a twist. What twist? There are 2 terms. One is called flood, the other is called no flood. There's 2 subterms inside this. ARP inspections flood, ARP inspection no flood. We'll see what the difference between these 2 are. Now this is the only confusing part in ARP inspection, which most of the people don't understand. But if you keep your head straight, this is easy to understand. Okay, so let's do that first. What I'll do is I'll go here. The command is ARP inside and outside. Inside. What is the host name on the inside? 10.11.11.1. What is the MAC address? Go to R1. Copy this. Come here. Paste this. Done. And ARP outside 11.2, the MAC address of R2. So go in here, interface FA00. This is C202. right? So this one, enter. I have just created the table. I have not applied it. I have not applied ARP inspection yet. So right now, if R1, when he's talking, if he changes his MAC address, he should be able to talk, right? So different MAC address. Now R1 is not R1, R3 came into this place. R3 came in, or R2, whatever came in, some different guy came in using the same address. He was allowed to talk in. Why? Because I have not enabled the service yet. So I'll do that. How? This is R1. To enable it, first we'll use the no strict mode. The no strict mode is also called flood. No strict. It's not strict. Okay? Flood is easy here. Think of it as flood is easy. It's not strict. No flood is strict. ARP inspection, not here. On the firewall. ARP inspection. Which interface do I want to inspect? Right now inside. Enable using, I'll say flood. Not strict. What is the difference between flood and no flood? We'll see. First we'll try what flood is. Okay. I have changed the MAC. The MAC is 11. Yeah, I'm trying to go from inside to outside, so I have to enable it on the outside. ARP inspection, outside, enable flood. Why? Because the ARP is for whom? 10, 11, 11, 2. Right? R1 ARPs for who is 10, 11, 11, 2. R2 sends out the reply. So the flooding I'm doing is checking where? On 10, 11, 11, 2. If I wanted to check on 1, I would have to telnet from R2 to R1. Do you understand this? So it's in flood mode right now. But he's not replying. I changed the MAC address of R1. What if I change it back? No MAC. It's working, right? But check this out. I change the MAC address 1.1.1. It will not work. I'm pinging myself. 10, 11, 11, 2 will not work, right? What if I also change the IP address? I'll make it 11. It works. Do you understand? When I changed the MAC address, use the same IP address, it did not work. But when I changed both, it worked. Confusing? Show run ARP. He checks that this IP should come in as this MAC address. If this IP is coming in as a different MAC address, not allowed. But a different MAC address, different IP address. Let's check another one. Now, if some other guy comes in with a different MAC address, it'll be allowed. Right? Whatever is in the ARP table right now, the IP is 10, 11, 11, 1. 10.11.11.1 cannot come with a different IP address, MAC address, sorry. 10.11.11.1 cannot come with a different MAC address. But if someone else comes with a different MAC address, he will be allowed to come from inside. Plus, this is the twist. What if someone else, 10.11.11.11, comes in with the same MAC address? Will he be allowed to come in or not? Let's try that. Conf t interface FA00, no MAC address. So what is the MAC address on this interface now? The one which is in the ARP table. This is in the ARP table, right? And the source is 10.11.11. It is not in the MAC table. What if, let's try. This is also allowed. This is also allowed. Told you, it's not strict.
If it matches exactly in the ARP table, then it will work only.
Not exactly, not exactly. Only the IP. Only that IP is not allowed to come out using something else. Do you understand?
Can you repeat the combination?
Yeah, the combination again, yes, of course. Let's try again, one more time. Let's keep this somewhere on the side. This is the table I have. Okay, this is the table I have. I'll move it back to normal. IP address is 10.11.11.1. Normal. It matches right now whom? This. So inside 10.11.11.1, using this MAC address, we'll try to go out. Should he be allowed? Obviously he should be. So let's try. He should be allowed because it matches the MAC address table and everything. Allowed. Now, same IP, different MAC. Not allowed. Same IP address, different MAC. Let's try. Interface FA00, MAC address. Not allowed.
With a different IP, we can do it with the same.
This is not allowed, right? Only this is not allowed. Everything else is allowed. Only if 10.11.11.1 comes in with a different MAC address, it is not allowed. But interface FA00, IP address 10.11.11.100, a different IP with any MAC address, does not matter. Right now is coming in with 1.1.1. This should be allowed. It is allowed, right? And if he even comes, this is fine, with the same MAC address which matches what? This. Now his MAC address is this, but IP is 10.11.11.11. That is also allowed. That is also allowed. So only with flood, you only have only one part, which is that he protects your IP. Only protects that IP address. So your default gateway is, for example, 10.11.11.10. You'll put that default gateway in there. You'll say 10.11.11.10 MAC address is this. Now 10.11.11.10 can never come from anywhere else. 10.11.11.10 will always be your default gateway. No one else can represent 10.11.11.10.
If I understand, it is multiple devices can use the same MAC address.
Yes. Yes. MAC spoofing is possible here. With flood, MAC spoofing is possible. ARP spoofing is not, because no one can represent 10.11.11.1. but someone else can represent your MAC address. 10, 11, 11, 11 can represent the same MAC address. Is this clear? Now, if that is the case, what does no flood do? This was flood. What does no flood do? I'll go in here. ARP inspection, inside enable no flood. Outside also I'll change it to no flood. Show run ARP inspection. Now it's no flood both. Let's try now. Go back to normal first. Normal IP, normal MAC. So should be allowed to go because it matches everything, right? And plus, if MAC address is changed, should not be allowed. Make sense? What if here IP address is the same, IP address is different, MAC address is the same, MAC address matches? Not allowed. This is the difference. It also protects the MAC. In no flood, no one can represent either this or this. Yeah, no flood, obviously. Do you understand? Your MAC is also preserved, your IP is also preserved. But again, if someone else comes with a different MAC address, that's fine. With the MAC address of anything else, this should be allowed. I guess no. Everything is protected. From this interface, which interface? Inside. No flood, right? So everything should match what? Full strictness. Complete strictness on the inside. Do you understand? Now from FA00, show interface FA00. Right now, a completely different stranger is coming. 10, 11, 11, 11, 0, 0, 0, 1. He's trying to go out. Flood only protects your IP. No flood protects your IP as well as your MAC, both. Very strict. So no flood you'll use when? When you know exactly all your piece, whatever is in your inside, you have created an ARP table for it. Full protection. No flood you'll use to protect your default gateway probably. But again, you'll be vulnerable to MAC spoofing attacks. Cam table attack. Cam table attack is possible. What do we mean by cam table attack? Yeah.
No flood is strict and flood is easy.
No flood is strict, flood is easy. Flood is easy. No flood is full strictness. No one is allowed from inside. Unless he goes back to his own IP as well as his own MAC. IP address 10, 11, 11. Okay. Full protection. Is this clear? Clear?
So please repeat that when we use flood and no flood.
When do we use flood and when do we use no flood? Flood is no strict, right? Not too much strict. Flood will protect your IP addresses. So use flood on the inside. Flood means 10, 11, 11, 1. Cannot be represented by any other MAC address. So tomorrow, someone else cannot remove your cable, plug in cable, put the IP address and try to use the network. That is not possible. Not possible. Yes, if someone else plugs in, uses a different IP address, possible. Someone else tries to spoof your MAC address, then use your IP, possible. Someone else uses your MAC address, uses a different IP address, also possible. You understand? In that way, it's possible. But with full strictness, no flood, what happens is no one else can use your MAC address, no one else can use your IP address, and no one else can come from that interface except for the same IP, same MAC. From that interface. Same. See, on the firewall, there's only one interface. Only one interface. Yes, if you want this to work, what you could do now, say you have another guy coming in from F11, some different guy is coming in from there. What you have to do in that case is ARP inside 10, 11, 11, 11 and the same MAC address, which is, tell him that this guy is using the same address. Right, so inside you have two now. This is also from the inside and this is also same MAC address. You'll be able to go. Okay. So new devices you add, you'll keep on adding ARP inspection tables for him also. New device, ARP, new device, ARP. Strictness. Okay. Flood is not generally used. Flood is not generally used because your MAC is still vulnerable. Good?
In case of DHCP, the IP can change.
At that time, it's not even very useful, ARP inspection here. You would definitely, DHCP you'll have to understand, on a transparent firewall, you only have two devices, one on this side and one on this side. It's not like you'll connect like a switch, you'll have 48 ports and all of them are connected, all of them are getting IP addresses. No. It's usually used, one side will be the server, the other side will be the default gateway. So you wouldn't really have a DHCP server. So you'll just use ARP inspection, no flood. One side is your server, the other side is your this guy. Right? That's the general principle of how we use this. Only two interfaces. Good? That finishes your ARP, except for one part. That one part is NAT. Now NAT will not do today. We'll do it tomorrow when we do 8.4. When we start 8.4, we'll start doing NAT in there. But today what I want to do is, I want to install the image on 8.4. We'll connect to the rack and we'll install the image in one of the 8.4s right now. So at least tomorrow we don't have to do that. We can just start with transparent firewalls. The concept, no different now. Your firewall is finished, by the way. It's all done. Conceptual wise, everything is done. Now the only thing is implementation. On 8.4, commands are different. The process is the same, but we will still repeat the process while we are doing it. We'll have a good overlook of what we have done before. So natting will be repeated. Transparent firewall will be repeated tomorrow. Transparent firewall tomorrow, natting day after tomorrow. Then the only thing left is VPNs. Okay, let me close this first. I don't want to make this a big recording. It's still 2 hours.